I love this type of question because it's got a very clear trap and lots of people are going to fall for it. So the best way to avoid it is to not trust yourself. This will be later in the math section. Use your calculator to actually pick some numbers and try them out. Try your hunch out in the question. Don't just go with whatever feels right here. You need to prove it. So even without a calculator, we can do it. So let me show you what we're going to need to do. First of all, let's just pick an easy point to plug into this equation. Well, what happens if t is equal to 1, right? 1 year is going by. Well, then this exponent would just be 1. And so all of my math would really come down to 16,500 times 0.87. And with the calculator, because this is the calculator section, I could just do that and get an actual number. But I'm not even going to do that because I still just understand that at some point, I need my value to be 16,500 times 0.87, even when I start changing the units, right? So what's going to happen if I'm changing to months? Well, if the same number of months pass, I should have the same value, because even though the equations are measuring in different units, they're supposed to be about the same exact car, whatever this is. So what happens? Okay, 1 year, t equals 1, is mathematically supposed to be the same as m equaling 12, right? The number of months should still be a year's worth of months. So, okay, we would want to plug 12 in for m and have the exact same result. So if we do that for c and d, it's not going to work. First of all, we're creating a huge exponent on the top, but also 0.8188, 0.988. These are just random changes to the percentage. That's going to mess with things. We don't want that. What happens next? Well, with the calculator, again, we could do this, but we don't even need it to see why choice A is the correct answer. If we plug in 12 to choice B, which is what most people pick, that's the trap choice, we would see that the exponent is really 12 times 12, 144. But remember, our exponent is supposed to be 1. We're supposed to raise 0.87 to the first power, meaning it's supposed to not change really at all. And if we do that in choice A, and have 12 over 12, which equals 1, we see that our exponent is consistent with what it was when we did the equation in terms of years. This little arithmetize, even without doing all the elaborate calculations, is really helpful. That's the point of these strategies, is to take the guesswork, the logic, the abstractness out of math and make it concrete, make it visual, make it something that you can see, so you can prove your answers correct, because there will be traps, and so you can't just take for granted that you have a good hunch for what's right. Prove your hunch correct.